Hello, and today I have a very special creation to show. This is a counter-rotating rotor helicopter. I've in the past I've attempted to make many helicopters, many helicopters, but none of them have quite worked. Either due to being just too finicky or not being able to produce enough lift to work reliably. Um, but one key thing is none of those used a counter-rotating rotor mechanism. Actually, this helicopter has a few key differences to some of my other helicopters. The first of which being obviously that it has a counter-rotating main rotor, and the second of which is the manner in which the rotor blades are being controlled. They are just set up on a controller to control the angle of the blade. When it gets a signal, it angles itself. Most of my other helicopters, all of them have used a lever on which a piston is attached to very quickly change the angle. And the reason why I use either these two setups is it's very difficult to replicate a swashblade mechanism in this game. Um, Along the main drive shaft of a swashplate mechanism around the collar that slides up and down to control the sum of the lift is a sphere that the swashplate is attached to, or at least this is the design that I'm familiar with. And the swashplate rotates along the sphere, um, in that sphere with a hollow section, and it slides up and down on a collar around the drive shaft. The issue is you can't easily make a sphere in this game to confine said mechanism. The next best replacement would be if instead of having a collar that it slid up and down on, if the whole drive shaft was designed like a sliding rod in this game, and if instead of using a sphere, if it was using a gimbal. Um, I've attempted to replicate a mechanism like that, but it would have to be very big, and at the scale I was working, I couldn't manage to get an internal connection mechanically for the gimbal without without its range being limited too much. The counter-rotating mechanism inside it, is this mechanism. You can think of it sort of like a differential, only imagine its housing, instead of being the thing that's rotating, it's stationary. So there's just this collection of gears in the center. Um, and now this red shaft here would be the driving shaft. This is what's connected to the engine on the helicopter here. Um, it's driving the gear on the top and the gear on the bottom, and then this one on the other side, uh, which goes to the tail rotor. Um, Now, you may see there's blocks going through other blocks, and you might say, well, that's not very realistic. Uh, I've had to make compromises in order to achieve the same result. If I were to, say, design this in real life, I would use a ball bearing mechanism inside the gear on the top, where the gear on the bottom is then connected to that, supporting the shaft on the inside. Um, and there would be no parts going inside of other parts, and that would work all fine and dandy. But since you can't have something like that in this game, you can only have surface to surface connections, more or less. You have to have um, that mechanical energy get transferred to it by some other means, and that's where these collisionless parts come in. It's it's a different method to achieve the same result, and that's what's so nice about it. Um, this is to power this whole thing, it's using a piston engine, much like some of the others that I've made, only it's using um, 3 piston blocks in parallel per quote-unquote piston, I guess, to increase the torque. This whole engine has been optimized for torque with low part count. Um, and 2 and 3 and 4 and 5 are the controls, like always. Number 6 engages that clutch. Um, to you may see how strange and complicated the control mechanism is with pistons uh, hitting other sensors and things. And the reason for this is most of my other helicopters use a like a plate or disc on the bottom where the sensors are attached, and then pistons come in front of those, connected to their corresponding rotors. And the disc can be angled forwards or backwards to fine tune it for the precession and any delay in the signal. Um, Now this, I've had this set up so that I can more or less completely um, shift the whole control system forwards, backwards 90 degrees or 180 degrees to tune it for the precession. Um, and then the internal mechanism here uh, does a similar thing where blocks are being pushed in front of sensors that are each going to their corresponding rotor blades. Um, since it's not using uh, the mechanism where the rotor blades are connected on levers controlled by pistons, the reaction speed is very, very slow. So flying it can be quite hard when it gets moving fairly fast. It's pretty easy to hold in more or less a hover position. Um, um, it's pretty easy to hold in more or less a hovering position, but if you really get moving, that's where things like how relative crosswind can come into play. I know most helicopters, no, really all helicopters, are capable of angling their rotors such so that the angle of attack to the air is decreased on the oncoming rotor blade and increased on the receding rotor blade, such so that the lift stays symmetrical across its travel on top of already what the swash plate can supply. This isn't really capable of doing that. First off, really because it can't measure its airspeed, and because there's no easy way to dynamically scale it with this mechanism. It's really either on or off. Uh, the tail rotor is, it can control turning. Um, the main rotors are obviously counter-rotating, so that solves that half of the problem, but you still need to steer it side to side. And now, with a normal counter-rotating rotor, you could speed up one rotor and then slow down the other to induce a rotation in the yaw axis. But this all can't do that since it is mechanically bound so that the sum of their rotation is always, well, zero, or at least they both move at the same speed in opposite directions. Yeah, if you summed up their rotational vectors, it'd be zero. Uh, Um, so the only way to control yaw is with a third rotor, and that's the tail rotor. Um, Putting too much strain on the engine, like holding all of the keys, can manage to slow the engine down and potentially stall it. Yeah, just like that. Um, but it's not that hard to start back up if you can disengage it. Um, this is using a mod to supply the wing blocks used as the rotors. Other than that, this entire thing is made of vanilla game parts. Uh, and I guess that'll be all. I hope you liked it.